Alright, so this is going to be 4.1 and 2. In 4.1 and in 4.2 you're going to learn two basic things. Okay? You're going to learn inverse functions in 4.2, and you're going to learn exponential growth, exponential decay in 4.1. Okay? So that's going to be MTS ALG2, and then this is going to be Chapter 4 notes. And then today we're going to do HW 4.1, HW 4.2. Okay? We're only going to get to part of that in this period. And then the other part we're going to try to get through the next period. Okay? And then the rest you have to do on your own as homework. Okay? And then tomorrow we'll be working through the rest. You have 16 days to get done with Chapter 4, get the test done, and then prepare for the final, which means you have to do a final over Chapters 1, 2, 3, and 4. Okay? Alright. So, let's get moving. The exponential function looks like this. This is the basic exponential function. So, when you're adding R, sorry, it's missing a T here. When you're adding R, okay, that means it's a growth. If you're subtracting R, it means it's a decay. Okay? So, it's either going to be growing or decaying. Okay? And so these graphs look either like this, okay, or like this. Okay? Very simple. Alright? And typical growth we're talking about is like when you put your money in an investment and it grows at a certain rate. Okay? Typical decay, very common decay, is in chemistry, where if you have isotopes, radioactive decay, right? So over half-lives you have this period of decay. And so that's a very typical way of doing both growth and decay. Now we'll probably have a lot of different ways of doing that. So either things are going to grow or decay. Grow plus R. Decay minus R. What does everything start with? This is your final amount. Your A with respect to T, with respect to time. Okay? The reason why it's respect to time, because this is what we said, exponential growth, right? Exponential growth means your exponent is your variable. Okay? So that's different than anything we've done so far. Before we were doing cubic, quartic, quintic, right? So your variable was being raised to the second, the third, the fourth, or the 1/2 power, right? For a square root. But in this case, your exponent is your variable. Okay? So that's the difference. So as your variable grows, your exponent grows. Does that make sense? And that's what exponential growth is all about. Because it grows exponentially, meaning it's growing very, very, very fast. Okay? Okay. So your final amount is equal to your initial amount times 1 plus your rate. Now your rate is usually like 5% growth or 8% growth. Does that make sense? So when you do 8%, that's really 0.08. 25% would be 0.25. Does that make sense? And so the reason why we're doing 1 plus that is that way we take 1 times your amount, which is your amount, right? And adding to that would be your rate. So then we don't have to add the amount later. Like remember in second or probably 4th or 5th grade when you did simple interest and they always did, okay, multiply it by 0.05, right? And now add your original amount, which would have been a lot easier just to multiply by 1.05 and get your total amount. Does that make sense? That's all this is. So simple interest just takes away the t. Okay? Compound interest, right, means that there's time periods we're going to talk about. Okay? But with compound interest, we get another equation that's similar to this, but it's a little bit different. Okay? So we'll worry about compound interest, but this is a basic exponential rate, exponential growth, exponential decay function. Does that make sense? Okay? And then the basis of this is that you have a function that is equal to a base raised to the exponent. Okay? And to deal with these, we're going to learn logarithms. Not today, tomorrow. Okay? And then the other thing that we want to deal with is inverse functions. All the inverse function means is that the x becomes the y and the y becomes the x. Okay? So you're just switching the x and the y. So if you have y equals x squared, then the inverse function would be x equals y squared. And then you would solve, right? And you would have y is equal to the square root of x, because you square root both sides, right? And then you have that's your new function. That's the inverse. Okay? In this case, you have 3x minus 2 is equal to y. The inverse function means, well, then x is equal to 3y minus 2. And so then you would have x plus 2, right? And then you divide the 3. So you'd have 1/3 over 3 is equal to y, and that would be your inverse. Okay? Because you had to do, everybody on the block gets the paper, so you divide 3 by everyone. And there was a 1 in front of your x, so that's why it's 1/3. Saw the question in your eye. But does that make sense? Went a little bit fast, but all it is a simple inverse. We're going to go over that today. But all you really do is switch and then solve for y. Because remember, we always put in terms of y. Right? So we have a new function. The function with respect to x. The function with respect to x, or in other words, f of x, is always y. And that's why we solve for y. Okay? Those are the notes for 1 and 2. That's pretty basic, but it's a lot. So now we're going to go through those problems. Questions on any of that first? Like switching the x and y. It makes kind of sense, right? It's easy. Switching the x and y. Okay? Exponential function means that the function has an exponent that's a variable. That's it. And your basic exponential function is going to be that the a with respect to time, the amount with respect to time, is equal to the initial amount times 1 plus the rate raised to the power of the time periods. Okay? All right, so let's do some work.